Now someone will frown and say duplication. Why? Sandy Met said duplication is far cheaper than the wrong abstraction. Yes, you need to start getting comfortable with duplication until you can identify that the behavior is shared and you're not just flying off the radar.
I don't want to go fully into her specifics in this talk, but I really think this is an important topic to have about abstractions, when it's good to have them, when it's bad to have them, and what's up with abstractions. So I will invite Abby here, and I will invite you to applaud her.
Hello, everyone. My voice is loud. Good to have you all here. Today I'm going to be talking to us about abstractions, friend, foe, or frenemy. I know the topic does sound dramatic, but who doesn't love a little drama? So yeah, let's go. But some introductions first. So my name is Abiodun Olowode, AB for short, so don't bother if you can't pronounce it. I'm currently the CTO and co-founder of Metrifox. I'm based in Essex in the UK. I'm originally from Nigeria, lived a bit in Spain, worked for Factorial for 3 years in Spain, and then moved to the UK and worked for Clio before I started Metrifox. So yeah, that's a bit about me. As I said earlier, we're going to be talking about abstractions, friend, foe, or frenemy. And we're going to be looking into what an abstraction is not, and then what abstractions are really, what makes a good versus a bad abstraction, when is the right time to introduce them, and when that right time comes, how should we go about thinking about them? And then we'll have code examples all the way. So I'm going to start with a statement. Developers love abstractions. Is this true? Is this too much of a blanket statement? Is there anybody here who hates abstraction? Okay, is there anybody here who has a love-hate relationship with abstractions? I see you. Okay, so it's not pure hate. Okay, so let's go back to first principles, yeah? Let's say you're wondering, okay, I'm just a new dev. I really don't know what abstractions are. Let me give you a very popular, quick example. Let's talk about the coffee machine. So, without an abstraction, yeah, you need to know how to brew the coffee, how to grind the beans, and you have him giving you tips and tricks, where he's telling you, don't grind so fast, or put the filter, wet the filter, and all he did yesterday. However, with an abstraction, you don't need to bother about him. You just press a button and you still get your coffee. In code, this will look something like this. Everything he said. He said, go to Switzerland because they have good water. And then he said, grind the beans slowly. I remember him saying exactly, not so fast. And then you go, and then he said, smell before tasting, right? And all these things he said. So, but with an abstraction, you would just call the machine that make your coffee, and then you get it. You don't need to bother about any other thing. So that brings me back to my previous statements. With that context, are there people here who still do not love abstractions? You're changing your mind so fast? Are there people here who still have a love-hate relationship with abstractions? Okay, I see you, and I factored you in, so I changed it. Many developers love abstractions. And why wouldn't we? If I had to do something that required 300 lines of code and you gave me a one-liner that could do the same thing, of course, sign me up. It is such an indescribable feeling. And I like to term this stage the friend stage. And Ruby makes it so easy for us to get into this friend stage. And then as Rails devs, we are spoiled in the best way possible. Because we thrive in abstractions. We have active record, action mailer, before actions, a gem for everything. So we are like spoiled babies. These abstractions help us get stuff done faster. And I like to think that it's this same comfort that we get from Rails and the likes that we try to bring into our own applications when we then begin to create our own abstractions in the systems and the applications that we work with. Some companies go even further and they have teams like a building blocks team, a platform team, a core team. I used to be on the building blocks team. I was hired at Factorial on the platform team, then building blocks team, then we moved to core team, and then I ended up on the DX team. These are a group of individuals whose major responsibility is to create abstractions so that the rest of the devs do not have to reinvent the wheel. So basically, I remember having to build an approval system, and it was because we had an expenses domain, like 5 devs. They needed expenses to be approved. Then we had the time off. They needed those to be approved. We had contracts that also needed to be approved. Then we had payroll. So we had so many teams that actually needed approval. So our team had to build an approval system. So basically, abstractions are there to make our lives easier, and oh, how we love them, well, until we don't. So, have you ever tried to use an abstraction, let's say a notification one, and you're like, my email didn't send. I don't know why my email didn't send. And then you start clicking into the files that make up the abstraction. And before you know it, you're like 5 layers deep in something called notification, context, runner, proxy, decorator. And the only question you can ask yourself is, how did I get here? Let's take an example. Let's say you're trying to actually generate a PDF, and you pass this myriad of parameters that are required, and you're like, yeah, I'm sure this will do the thing. And then it doesn't do the thing, and you say, okay, let me go into the PDF generator class. I'm sure that's where the thing is happening. And then you go in there, and what do you see? It's calling PDF document, and it's passing all your parameters to this same one. And you're like, okay, I get it. I'll just click into this class, and I'm sure that when I get in there, I'm going to see the thing that does the thing. And then you get in there, and it's just another class. Oh, behold, another class created just to forward something somewhere. David Wheeler said, all problems in computer science can be solved by just another level of indirection. And then someone added a caveat, and he says, except for the problem of too many layers of indirection. So we have classes that have just been created to forward stuff somewhere, and you just get lost, and you don't know how you even got there in the first place. There's another thing you could encounter, which we call death by configuration. Who has ever been there? Or you don't know what it is. I'll explain. So you want to use an abstraction, but then you have to go configure certain things in like 5 different places. So you come here, and then you add this thing. Let's just see it. So you want to maybe have this email, and then you first of all need to go to the initializer for jobs and initialize it there and add low priority retries, blah, blah, blah. And then you need to go somewhere else to say exponential backoff, blah, blah, blah. And then you need to now create the class, and then to use it, you need to call job runner.run something. And at the end of the day, you're like, I could have just done the thing myself in just one line, and I would be done. Why do I even need this? At the end of the day, this is how people get into what I term the full stage. At the beginning, you're very glad that someone created this abstraction, and you don't need to do it yourself. You don't need to start afresh. But then as you begin to interact with it, you begin to realize that it was just a trap. And this is what I've termed trapstraction. Because you thought it was an abstraction, but it just ended up getting you stuck. So in order to be able to identify what an abstraction really should be or really is, maybe it does help to talk about what an abstraction is not. First of all, abstractions are not a way to hide messy code. We've all been there, right? Where something is very difficult to understand, and instead of cleaning it up, we just chuck it into a class somewhere, and it becomes an abstraction. But spoiler alert, hiding a mess doesn't make it any less messier. So do we really need that new orchestrator service that you just created, or it was just created to hide the things that don't look so good? Sometimes what we need is a refactor, not necessarily an abstraction. If the refactor does lead us to an abstraction, that's fine, but we don't reach out to create abstractions. That's not why they're there. Secondly, abstractions are not the path to making code elegant. Abstractions are not the path to making code elegant. Sometimes you're like, I want this code to look so good that when someone reads it, they're like, whoever wrote this must be a professional. And then we go the extra mile. Take a look at this. We have a name fetcher class, and we say name fetcher.fetch user. It sounds cool, right? So you do the fetcher.fetch product, and it returns what? Response. What does it return? If I do name fetcher.fetch product, what does it return? Product.name, right? Yes or no? Okay, if I do name fetcher.fetch invoice, what will it return? Invoice? It's right there, right? Right? Now, we have this class. What will it take us to have just done user.name, product.name, invoice.name? Why do we need this? This is totally unnecessary, and it might sound cool, but elegance is never about doing more. Elegance is about clarity, and clarity never comes from an extra layer. And I could spend the whole day talking about what an abstraction is not or shouldn't be, but as you know, we don't have a whole day. So what is an abstraction really? An abstraction is a simplified representation of something complex that lets us think about the what and not the how. Coffee machine, keep it in mind. It lets us think about the what and not the how. Now, let's not mistake complex for messy. Two different things. In code, abstractions could look like shared utilities, service classes, interfaces, but it's more like, I do not want to know how this works, I just want to know what it does. Abstractions are meant to hide the details and expose intent. Sometimes that's where I see that we actually get it wrong. Abstractions are meant to hide details, but then they're meant to expose the intent of what's about to happen. Coffee machine dot what? Make coffee. But this is an abstraction. So this doesn't expose intent. It tells us nothing at all. And now we have to go into this class to figure out how it does what it does to then determine the what. That's already a bad abstraction. And I know that you may say, AB, no, AB, no, AB, this is just bad naming. I'm sure that this class has something it does. This is just, naming is hard. But really, could that be the only reason? Is it possible that we weren't supposed to have created this abstraction? We don't even know why we created it, and we just lumped a couple of things together in one class, and now we call it user orchestration service. What exactly is it orchestrating? No idea. So let's talk about when is the right time to create an abstraction. Now, things are about to get really interesting. We've all heard about this, right? In PRs, you see it everywhere. Don't repeat yourself. Keep this dry. Seniors flexing all their muscles. They're like, keep this dry, extract this, make it an abstraction. We were all guilty of this, even me, years ago. And many times, things look the same, but they do not act the same, and then we request that they be made dry just because they look the same. Spoiler alert. Abstractions should be about behavior, not structure. When you request that an abstraction should be created, it should never be about they look the same, their methods have the same name. A quick example. Now, look at these two classes. If you see this on a PR, yeah? You're like, render summary, total due, total. Report renderer, render summary, total due, total. Why are we repeating this? So you tell your developer, please, let's not repeat ourselves, keep this dry. And then they say, okay, boss, I'll do that. And they do this. They extract render summary, total due, and now we have our invoice renderer, and it inherits from the base, and we have report renderer, and all is well in Israel, in the land of the living. But then, one of these is financial, the other one is analytical, and 6 weeks from now, their summaries are going to diverge. And you're going to be stuck hacking conditionals into render summary because they have diverged. because they were never the same in the first place. But you could say, oh, no, AB, I know exactly what to do. I'll just override it in my own class as a boss that I am. I'll just say, someone just had that thought and I said it. And then you say, okay, so on the invoice for company.name, now they've totally diverged. And this one is saying total incidents, like, would you have thought that they would diverge in this way? Now we're here. So, but look at something. We now have a base class that adds absolutely no value. We have a base class that introduces unnecessary inheritance. We have a base class that introduces coupling for no reason at all and no benefit. How did we get here? We got swayed by structure instead of behavior. You need to let abstractions call out to you. They need to be glaringly obvious, and it needs to mean that duplication adds no value. So I'm going to go back to the question I asked just before we started this section, and it was, when do we need an abstraction? And it's just one simple answer. Just one simple answer, and that is when we have shared behavior. That's it. If you cannot identify shared behavior, you do not need an abstraction. What you need is probably a refactor or just duplication. Now someone will frown and say, duplication, why? Sandy Met said, duplication is far cheaper than the wrong abstraction. Yes, you need to start getting comfortable with duplication until you can identify that the behavior is shared, and you're not just flying off the radar of structure. So now we've seen what's a good abstraction, what's a bad abstraction, and all the intricacies about when we should introduce them. But let's say we get to the right time and we want to introduce an abstraction. Let's talk about how should we create an abstraction. So we're going to create one together. We don't have much time, so we won't do live coding, but let's work together to create a notification abstraction. This is going to be interesting. So imagine that in our code base, we have several notifiers, and in every notifier, what we have is this. For example, time off approved. So when you want to notify people that their time off has been approved, what we do is we send a notification to the user, but we say, if the user prefers email, then you send the crafted email, right? If the user prefers SMS, then we send the crafted SMS. But if the user prefers push, then send the crafted push. So in another domain, still in the same code base, because we have several teams, remember, we have the performance domain, and they want to notify a user when a performance review season is open. So they do exactly the same thing. They say, if the user prefers email, send the crafted email. If the user prefers SMS, send it. And if it's push, send it. Now let's make this a bit more complicated. Now, this is actually real life. So then we have users who say, nope, 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 because I can decide what happens per event. When my time off is approved, I want a push notification. But when my promotion is approved, please, send me an email. But when my contact is updated, just send me an SMS. So now users are saying, I want to be able to determine what kind of notification I receive per event. So that means this entirely changes. So time off, we then have to say, what is the user's notifier setting for time off, right? Then it's that preference we use in sending them an email. Unlike before, it looked like, oh, every user just has one preference. But no, that's not how it works. And then in our performance review, we have what's the user's notifier setting for performance reviews? And then we do the thing that we do, which is send the crafted email, send the crafted push, or send all the thingies that we send. Now remember, we want to create an abstraction because we have like 7 domains that do this for every single notifier that they have. So how do we go about this? I'm sure someone is thinking now like, I think I already know how to solve this. I'm sure some of us have already We've done the whole thing in our brains. First thing you do when you want to create an abstraction is to identify shared behavior. So what's the shared behavior? I always try to actually write it down because that's when it's very clear. Not just off the back of your head, like, I think this is how they are. When you begin to write stuff down, you realize that, oops, maybe that's not really how it works. So what's the shared behavior? Get the user's preferred channel based on the identifier per event. For example, time of approval. Send a message based on the channel preference per setting. Yeah. And then craft different messages per channel. So remember, a text message is different from an email. Imagine that you receive a push, time of approved, as an email. That would be so weird. You just receive a one-liner. So all of the stuff that are sent are different per channel. If it's an email, it's different. You say, hello, Luchan, your manager, Bob, just approved your time off for 5 days. If it's a push, you just have a header, time off approved, and then you can click and go into the app. And then if it's a text, something totally different. So this is the shared behavior. Now, someone might be thinking, okay, I know exactly what to do. I'll just do this. I'll create my notifier class, and then I have the notify. Now, if you tell me the user, if you tell me the channel, and if you tell me the message, I can help you send a notification. If you send me the user, if you send me their channel, and if you send me the exact message, I can check, is the channel email? I'll just call the email sender. Is the channel SMS? I'll just call the SMS sender. And is it push? And now we have a beautiful abstraction. And you can just call me like this, notifier.notify, take the user, take the channel, take the message. Amazing. I, as the caller of this abstraction, already have the user, I have the channel, I have the message. Why do I need you? I could just do this. I already have everything, no? I have the channel. I have the message. I have the user. I can write this one line and say, okay, I know the channel. I've already seen that it's an email because I have to extract that channel and send it to you, right? So I have to find out what that user's preference is and send it to you. At that point where I'm calling your abstraction, I have all the details. So that brings us to one of the most important rules when we're creating an abstraction, and that is tell, don't ask. Here, we're asking for everything. When you ask, you end up writing methods that know everything about the objects that they use. When you tell, you let the object decide what to do with its internal state. Right now, you're saying, send me everything. Oh, what's your user? What's your channel? What's the message? And I'll help you do the thing. Nope. Nope. Behavior should always live where the knowledge is. That's exactly how abstractions should work. And the object with the data should own the behavior. It should be told what to do. It shouldn't be interrogated. You shouldn't say, oh, give me all of these things and I'll go do the thing for you. No. If it already has all of that data, tell it what to do with it. That's one of the rules of creating a good abstraction. Now, let's say we want to make that abstraction better. One of the first things we should do is, within shared behavior, identify uniqueness and where it would live. Remember that the first thing we did was what? Identifying shared behavior, right? We wrote all of that down. Now, the next thing is, I have seen the shared behavior, but within this shared behavior, are there stuff that are unique to each of these notifiers? So that's the next thing we do. And one of the reasons why we do this is it clarifies responsibility. Who should format the message? Who should send it? Who knows what channel to use? So in our case, what is unique? Each identifier is different. Did we actually realize that? Time of identifier is time of approval. Performance review is something else. So the setting that we check for each of those notifiers are different. So they are unique and they belong to the domain or the class, wherever they are defined. Now, each message is different, right? So the message you will send for time off is different from what you will send for promotions. So those are also unique. Even if it's shared behavior, they are all unique. So now, one way we could rewrite our abstraction is this, one way. We could say, okay, we have all these notifiers. Let's create a contract with them and let's tell them exactly what to do. So you are a notifier. If you were using sorbet, I know some of us here, or most of us might hate sorbet, but if you were using sorbet, you wouldn't need to raise any of this. You just define this as abstract, and when a class inherits, it just tells it like, you need to define these methods, so you don't need to stress yourself. But anyways, we can say that henceforth, every notifier needs to implement an identifier because it's unique to it. Your identifier is yours, and it's going to be different from every other person, so that's yours. I don't need it. Define it. Your SMS, your email, and your push are yours. So keep it in your domain. Keep it with you. I don't care about it. You don't need to send that to me. That's yours. But define it in your class. And then, now, these are the things that are unique, and we're going to say, every notifier, do your thing, flex as you like. And then, what do we do? If you want to see the code, I put it on a gist so we can go through it together if you care, so you can just scan. So the next thing we do is, we can then do this within our abstraction class. Now, the user is always going to be the same, right? You would always need a user, no? There's no other person that will be sending a notification to an inanimate object. It will always be a user. So we have that, and then we say, let's actually notify this user. Now, the way we check for the user's notification preference is the same, right? It would always be the same. It would never change. What changes is the identifier, but how we check is always going to be the same. We're always going to say, show me the user's notification preference by this identifier, and we get the channel. It's always going to be the same, so that's now in the abstraction. And then we then say, okay, based on the user preference, if it's SMS, do this. If it's email, do this. If it's push, do this. And then we can say invalid preference. Now that we have this, let me now show you the beauty of this abstraction. This is what time of approved notifier looks like. In this notifier, all we did is, our identifier is time of approved. And this is our SMS message, this is our email message, and this is our push message. That's all that exists in this notifier. And then the wonderful part. When we do this, we absolutely have notified the user. And then every single notifier can just define their identifier, their messages, and that's all. No stress, nothing else. You don't need to pass things across the river, across the ocean, just because you want to get something done. I read the code quickly, and yeah, that's what you have in your gist. I started to run it, and I intentionally left the body stuff, so it just looks funny that you send this, so I just started to leave it there. Yeah, so I created a new user, a new phone number, email, push token, and I just called the notifier, and that's what I got, sending SMS. You have the gist, so if you look at it, you see all of the code, notification channels, and that's it. And now, this brings us to, what's the goal of a good abstraction? It should preserve clarity. You should never be confused about what exactly is going on. You should never be confused about what's about to happen here. Then it should be easy to use. Please never make me send you 10 parameters. Never make me send you my whole history and my generational history. Oh, my grandfather's name is this, and my village is this. No, please don't do that. If I have the data, tell me what to do with it. And then expose intent while hiding details and complexity. One of the speakers said, there's a lot of complexity in Rails, but we don't see it. All you do is say, has many, and it's simple. It's easy to use. That's the aim of every good abstraction, to be easy to use. If I have to go configure something in 15 different places, spare me. I'll just do it myself, because this is torture. And that's how we get into the fourth stage. That's why we have many people here who have a love-hate relationship with abstractions. And then keep behavior as close to data as possible. So, closing thoughts. Duplication is fine for now. You know when they say doing bad things is nice, feels good sometimes. Now, I just have that feeling of making you all say duplication is fine for now. Because I feel like a lot of developers struggle with it. Struggle with duplicating code because we've been brought up to keep everything dry. But duplication is okay until you can identify shared behavior. Secondly, behavior would beat structure every time. Where abstractions are involved, behavior beats structure. Next, tell, don't ask. And this is the most important one. Best use of a tool is to not use it unless you need to. That's the best use of a tool. Don't use it unless you absolutely need to. 1 year from when you create your abstraction, you don't want a dev saying you took everything from me just because they tried to use something that you created. So thank you for listening to my talk. And this is me.
Thank you very much.